To DYNAM or not to DYNAM? That is the question to be explored in this video. When a program is invoked using a variable, most programmers state that it is a dynamic call. Call variable means the call is dynamic. Many programmers claim that the call literal is a static call. Others might look more closely and either agree or tell you that it is a dynamic call. Why is there confusion regarding the call literal? When it comes to the call literal, the answer depends on a compiler option. So those programmers that look more closely are correct. This is another episode of Dinosaur Parkour. Faster, better, mainframe programming. What happens when a program is compiled with the no DYNAM compiler option? What changes when DYNAM is new? Consider this program named 2DYNAM 5. The first line contains the compiler option DYNAM. Line 14 invokes A31BR14I using call variable. Line 15 invokes A31BR14L as a literal. A31BR14, I, and L are both do-nothing programs. They contain a single verb, go back. In the Enterprise COBOL manual, the call variable is referred to as the call identifier format. Call literal is just that, call literal. So to recap, Program 5 uses the DYNAM compiler option and invokes two programs. BR14I is invoked using the call identifier format. BR14L is invoked using the call literal format. This is 2DYNAM 6. It uses the no DYNAM compiler option, and it does the same thing as Program 5. It invokes 14I using the call identifier format and 14L using the literal format. Both Program 5 and 6 have been compiled. It is time to examine the executable object. This is the primary menu for IBM File Manager. Select 3 for utilities, 10 for load module utility, 1 for view load module. The Dino load lib is listed for the dataset, and the member name uses the pattern 2DYNAM asterisk. Press enter, and we see several members. We are interested in the last two, Program 5 and 6. Program 5 uses DYNAM, and Program 6 uses no DYNAM. Place an S beside Program 6. I want to look at the program compiled with no DYNAM first. A31BR14L jumps out. A31BR14L is part of 2DYNAM 6. So the call literal to A31BR14L created what is known as a static call. This is why many programmers tend to say that all call literals are static calls. If those individuals mostly code kits program, that is their reality. The CICS translator generally is set up to force the no DYNAM compiler option to be used. Thus, for a kits programmer, call variable means dynamic call literal means static call. However, that assumption might not be true for batch programs. Now it is time to look at Program 5, which contains the same logic but was compiled using DYNAM. A31BR14L is not there. The only modules included are IBM modules for LE and COBOL. The call literal was not treated as a static call. That is interesting. What does IBM say about it? This is from the Enterprise COBOL 6.4 Programming Guide. Use DYNAM to call non-nested, separately compiled programs invoked through the call literal statement to be loaded for call and deleted for cancel dynamically at runtime. Translation: DYNAM converts call literal into dynamic calls. Nested programs are excluded. DLL uses other rules. Long mixed program names are not applicable. Understanding the impact of DYNAM and no DYNAM makes you a better programmer. Now that the small print is out of the way, I use IBM File Manager and inspect the load module to determine if the call literal became an include module or not. File Manager is a value-added product. It had to be purchased separately. You might not have access. This JCL runs the AMB list utility, which is a standard utility that allows one to inspect object modules and executable. It is set up to inspect 2 DYNAM 6. It is asking for a module map, which is the shortest output. This is the output. It echoes the command request, followed by the module summary, which gives some info about how the executable was configured. Page down, PF8, page down again. Place the cursor on the numerical map title line. Since the scroll action is cursor, the page down action, PF8, move the line to the top. We can already see hints that call literal was treated as a static call. I'm going to type right on the command line. In the first resident class block, the cursor had been placed on the class location heading. Press enter. The output shifted right to left based on the cursor location. Now we can see clearly that A31BR14L is part of module 2 DYNAM 6. So based on what we just learned from program 5 and 6, some new terms need to be defined. IBM uses the phrase dynamic call identifier when referencing call variable name. The compiler option of DYNAM or no DYNAM does not impact how call identifier is treated. Call literals that are compiled with the DYNAM compiler option are converted to dynamic call. This is called dynamic call literal. Call literals that are compiled with the no DYNAM compiler option are treated as static calls. This is known as a static call literal. How the compiler handles a call literal is dependent on the DYNAM compiler option. The title of this video is To DYNAM or Not to DYNAM. It is my opinion that most program calls should be dynamic. Are there any benefits to using dynamic call literal? Many years ago, I argued that they should be used. Many years ago. Reason 1, call literal makes it very clear which module is in both. Call identifier allows programmers to get cute with how they create the name of the variable. For example, call WS do nothing program does not tell me the name of the 8-character program. I get the assertion that WS do nothing program tells me what the program is doing, therefore I do not need to look at the code. I personally still prefer to look at the code. Now I have to shift gears mentally and issue find WS do nothing first on the command line and hope the variable is defined in the program source. It seems half the time the desired variable is buried in a copybook. Now I have to figure out how to compile the program so that I can issue the find command on the compile listing. Once I have found the 8-character program name for the do nothing program, I'm going to view it. You want to know why? It might be doing something now. It might have been a do-nothing program when the original programmer wrote it, but got enhanced to do something 5 years ago. I get the argument that long descriptive variable names tell us what the program does so that we do not need to look at the source. I still want to look at the source, since maintenance can change how the program behaves. Plus, there's only so much info that can be conveyed in a 30-character name. Because I prefer to look at the program, it is my opinion that call WS A31BR14 is better than call WS do nothing program. Dynamic call literals are very clear about what is being invoked. That is a plus in my opinion. Point number 2. Dynamic call literals were faster than dynamic call identifier. That was a nice bonus. Consider these numbers. It is very clear that dynamic call identifier takes about 33,600 microseconds to invoke A31BR14 1 million times. It only takes about 24,700 microseconds to invoke A31BR14 using a dynamic call literal. The dynamic call literal is about 26% faster than a dynamic call identifier. It is important to know that these numbers came from a program that was compiled using Enterprise COBOL 4.2. You might be wondering why I am showing you the result from COBOL 4.2 since it is out of support. This shocked me. For the bulk of my mainframe career, dynamic call literal has been 20 to 25% faster than dynamic call identifier. The Enterprise COBOL for ZOS 6.4 Performance Tuning Guide states dynamic call literal is on average 20% faster than dynamic call identifier. But that is not what I got for my very simple test. The initial reaction might be to think that IBM tested programs that did stuff. No, they did not. This little bullet point says that IBM used subprograms that contain just the go back verb. Since we're looking at this page, this sentence expresses my opinion about dynamic versus static call. In general, it is beneficial to use dynamic call when the call structure of an application is complicated, the size of the subprograms is not small, and not all subprograms are called in a particular run of an application. I summarized that as avoid static call. They are more trouble than they are worth. With that said, it would be interesting to see if a static call literal is faster than a dynamic call identifier. This page says that it will be. Is that part still true? These numbers come from a program that uses the same logic, but the no DYNAM compiler option was used. The call literal is treated as a static call. The static call literal is 47% faster, which is not too far off from the 52% mentioned in the Performance and Tuning Guide. Even though this static call is 47% faster, it is still not worth the headache that comes when using static call, in my opinion. Let's look at the code. I have three programs that do the same logic. 2DYNAM1 was compiled using DYNAM and COBOL 6.4. The second program, 2DYNAM2, was used no DYNAM and COBOL 6.4. Program 3 used DYNAM and COBOL 4.2. The logic is the same between the three programs. The difference are in the display statement and the compiler option. This screenshot gives an overview of what is different. The logic being tested is coded the same. It invokes the get CPU routine once at the start of the program to force it to load and initialize itself. It called A31BR14 dynamically to force it to be loaded into memory. I do not want the load and initial setup to be a part of what is measured. If I had not done this line, I might assume that the load caused 188 microseconds of difference. Allow me to explain what's going on with the A31BR14 program name. There is no I or L at the end. Edit A31 asterisk. Press enter. There are 4 versions of this program. The version that end with I and L were created for this video. They were used earlier to show how DYNAM and no DYNAM impacted call variable and call literal statement. I plan to delete them after this video. The first program is the original version. That is the one that's going to be used for the rest of this video. The one that ends with the letter A is the assembly version. I'm going to use the COBOL version because that is what IBM said they knew. Back to the code review. Now that the modules are loaded, it is time to do the desired measurement. The program is going to run the measure call identifier test 5 times. The measure call literal test is performed 5 times. This program was compiled using DYNAM, so the call literal is treated as a dynamic call. This program is racing dynamic call literal against dynamic call identifier. Version 2 of this program uses no DYNAM, so that display on line 42 says static call literal. Program 2 is racing static call literal against dynamic call identifier. This shows how each test is configured. Get the starting CPU usage, call A31BR14 1 million times. Get the ending CPU usage. Perform the paragraph to subtract starting CPU from end CPU, which gives us the amount of CPU used to do 1 million calls. Because I was surprised by the results from the first program, I created program 3 and compiled it with COBOL 4.2. This is a recap of the numbers from the 3 test programs. I ran test program 1 and was shocked. I fully expected for dynamic call literal to be faster than dynamic call identifier. It was not. So I compiled the program using COBOL 4.2. Those results in purple are what I expected. The dynamic call literal is faster than the dynamic call identifier. Next up was to see how the static call literal compared to the call identifier. The static calls were faster. No surprise there. But there is another surprise. The call identifier runs faster when no DYNAM is used. I ran the 2 COBOL 6.4 tests 10 additional times. The low 27,000 for the DYNAM and the mid to high 26,000 for the no DYNAM is consistent across all 10 of those runs. That kind of implies that DYNAM and no DYNAM have an impact on how call identifiers are handled, which surprises me again. Remember this page? The description of the no DYNAM option clearly states call identifier statements are not affected by this option, but this simple test implies there might be an impact. Hey, IBM, what's up with this? The dynamic call literal is not faster than the dynamic call identifier, and it appears that the no DYNAM compiler option makes the call identifier a wee bit faster. To answer the question to DYNAM or not to DYNAM, if you're coding CICS, you have to deal with the no DYNAM compiler option. You must think carefully about using call literal because they're treated as static calls. For batch programs, my preference is to use the DYNAM compiler option. That allows me to use call literals and have the compiler convert them to dynamic calls, which makes me a happy camper. I just wish that the dynamic call literal were still 20% faster like the COBOL 6.4 Performance Tuning Guide claimed. Walnut. Translation: DYNAM convert call literals into static. It's on how call identifier is treated. Treated.